Alright, hello. I've got my project here, which is my renderer thing. So right here it is about 700 lines of code, give or take, probably less because of comments and white space, but and also I don't know if I really consider imports to be code, but anyways, I will start by showing it off. So right now it's pretty. This is it. It's just a window that renders a cool little effect like this. I was gonna write a shader to be a little bit more cool, but I decided I would just go for something extremely basic, like just like a sine wave color changing shader. And if we exit it, there's literally no errors, so that's pretty neat. These are the shaders. So this is the vertex shader, which is pretty basic. But then this is the fragment shader. So this is the thing that actually dictates the color on the screen, because this is the impressive part about this. It's not that it's a window or that there's an image on the screen. It's that this is all going through the GPU. So we're running this code on the GPU that determines the colors of these pixels, and we're flipping that image to the screen every frame, and this is running at like roughly 80-ish frames a second. Well, yeah, something around that amount. And the cool thing about it is there's a website called Shader Toy, and this is basically all Shader Toy is. If we click on one of these, it's basically just a shader that you could write for stuff and use math to do all this. So somewhere in here they have a time value that's changing over time, and this is all running on the GPU, for instance. Well, when I run my application, this is basically the exact same thing we get. In fact, when we click new, this is the same shader that I have in my program. When I do cargo run, there's the same shader. Give or take some like speed and like phase offset, but this is just sort of a demo to showcase that it does everything it needs to do. We can full screen it and everything's all hunky dory. Now the main things that I'm using to do this, I'm using Vulkano, which is the Vulkan API in Rust. Vulkan is a GPU API meant to be the successor to OpenGL. I'm using Vulkano, and I'm also using Winit, which is, it's not anything to do with Windows, the operating system, but it's used for making windows. Like this is a window. And then I'm using some standard stuff, mainly some things to synchronize different threads together. Just a very quick rundown of what's going on. This is my entire main function. We make an event loop and a proxy event loop, which we use for our other thread to interact with the main loop thread. Then we get the Vulkan driver on this device if it exists. This will just fail and throw an error if we can't get one. But we then just make our application, which is a custom struct that I made called application. This is how you do stuff with Winit. And then I tell the event loop to run the application that I made. We have some other custom data. If it has like buffer contents, that means these are going to be things that are stored on the VRAM of the GPU. This is my application struct. It has a whole bunch of optional things because I have a default implementation where all these are set to none because they can't be initialized until the window's been created. This is some of the useful functions I have on it. If I collapse them, you can see just basics of the names of what these functions do is basically what they do. So I'm not going to explain everything about how Vulkan works because I'm also a beginner to Vulkan, but we can build the window, which is part of Winit. This also makes the swap chain surface. We can initialize the GPU, the physical GPU, and this is then initializing the virtual GPU is making like a virtual machine for the Vulkan GPU. Then we build the swap chain. The swap chain is so that you could flip images to the Windows surface. Render pass, the frame buffers, which are the output of the render, we can compile our shaders, we build the pipeline. I'm not going to really explain too much about what that is. We get a command buffer, which is pretty simple. It's just like a queue of commands that we give to the GPU. We have a function for rebuilding our swap chain, because when the window resizes, we need to rebuild the swap chain because it's no longer valid because the size has changed. We have a function for submitting a draw call. We have, basically just a getter that gets the window's size as a U32. And then, this gets like the render format of the pixels, so like RGBA. But the meat and the potatoes of all this is this application handler trait. Now, this is part of Winit. You implement this on your application, and it lets you hook into Winit. So this is resumed. This will be called when the event loop starts. So at the start of the event loop, we actually get an active event loop, which is what we use to build the window. And then we do all of our initialization. And then we create another thread that basically it's going to submit a draw call, wait for that to be over. It's going to wait a little bit more, like a few seconds, just, so it's not drawing too fast. And then it's going to submit another draw call and repeat. This is the function right here that it does. And then also we have some other datas, like the render check, which is a reference. It's an atomic reference, which means you could share it between threads. And then it's also a read-write lock, which is basically a mutex. So only one thread can be reading and writing to it at a time. And so this you can change from any other thread, and then it will make this rendering thread stop calling, and then you can join that thread in when you end. But yeah. Here's the window event. This is called internally by the, once again, the application handler trait. This lets you hook into, like, when you press the X button, the close request goes on. So like I just explained, we set the continue render to false, and then the render notify thread we can join into it, and then we can just event loop exit, and this will close the entire application. Yeah, and then we just have some helper functions. This is for initializing the Vulkan driver. This is for locating the correct physical device, because we might have multiple GPUs, so we want to get the most optimal one. This is just the vertex buffer that I'm using. It's actually 4 vertices for each corner of the screen, so we have 2 different triangles. But yeah, that is my entire program. If I click cargo run, you can see we got this right here. Pretty nice. I could write any shader that I really want with it. Granted, I haven't passed any data for like the size of the window. I should ideally be doing that to so that my shaders can do more interesting things. But for now, this is all right. I feel pretty accomplished with this so far. Thank you for watching.